Good day everyone, my name is Mega Samson, an underlevel student in Lagos State University studying physics education, and today I'll be teaching you on motion. So let's get started. What exactly do we mean by motion? If you can tell an object's position is changing as time ticks by, basically it's motion, right? Yeah, it is. But that's the catch. Motion is relative. If you're reading on the bus, are you moving? Are you? Who knows? Relative to your seat, relative to someone on the sidewalk. Yes, the bus can basically be moving at 40 kilometers per hour. So anytime we talk about motion, we need a reference point. My first point, I'll be talking about the vocabulary of motion. Most students, they mix up terms in physics. So I make that mistake too. Let me start with distance. So distance is the total path you travel. Let me give you an example. Let's say you move from Lasu Gate to Yanoba, then from Yanoba to Post Service. From Lasu Gate to Yanoba, let's say it's 3 kilometers. Then from Yanoba to Post Service, 3 kilometers. So your distance is you moving from Lasu Gate to Yanoba to Post Service. That's 3 kilometers plus 3 kilometers. That's 6 kilometers. That's your total path traveled. That's your distance. Distance is a scalar quantity with no direction. 2. I'm going to talk about displacement. Displacement is a straight line from start to finish with direction. I'll talk about speed. Speed, is how fast the distance changes. Let's say a car was moving at 55 kilometers per hour, then it sped up to 60 kilometers per hour. That is speed. So next, I'll talk about velocity. Velocity, is how fast displacement changes. I talked about displacement before, that it is a straight line. That means from this point to here, it does a straight line. You know where you're going to. So velocity is how fast displacement changes. So that means a car was going from Iba to the Lasu Gate. Let's say it was driving at 20 kilometers per hour. Then it sped up to 60 kilometers per hour. That is how fast displacement changes. That means how fast the car moved. I'll talk about acceleration. Acceleration is how fast velocity changes. You get? Displacement is straight line from start to finish. Velocity is how fast displacement changes. Then acceleration is how fast velocity changes. You get me? So what I'd like to say next is you can have constant speed, but changing velocity is a circular motion. Yes, a car going 30 kilometers around a roundabout has constant speed, but velocity keeps changing because direction changes. Yes, it's a circular motion, so it's not going in a circle, a big circle. And changing velocity equals acceleration. So circular motion always adds acceleration even at constant speed. You can have constant speed but changing velocity. How? Circular motion. A car going 30 kilometers around a roundabout has constant speed, but velocity keeps changing because the direction changes. And changing velocity equals acceleration. So circular motion always adds acceleration even at constant speed. That's a fact. So next, I'm going to talk about the types of motion. We have translational motion, rotational motion, oscillatory motion, and random motion. So translational motion. Under translational motion, we have rectilinear motion and curvilinear motion. Rectilinear motion is motion on a straight line. That is a free-falling apple, e.g. a free-falling apple. Curvilinear motion, that is motion on a curved path, like a ball thrown. It's still translational motion because the object itself isn't spinning, just moving. So let me talk about rotational motion now. Rotational motion is the object. Rotational motion basically means the object spins around an internal axis, e.g. the earth, your bicycle wheel, etc. The earth does it once in 24 hours. Oscillatory motion basically means back and forth about a center point. So now let me use a pendulum as an example. Your heart beats an atom in a solid state. So if the restoring force is F equals to minus kx. Yeah, we call it simple harmonic motion. Yeah, now let me talk about random motion. Random motion basically means no paths, Brownian motion basically. So let's say a pollen grain jiggling in water because water molecules keep bumping them. So most real motion is a combo. The earth translates around the sun, the moon rotates around the earth. That the sun is basically the earth's axis. My third point is equation of motion. If acceleration is constant, these three equations work. V equals u plus at, meaning new velocity equals to what you start with plus how much acceleration is added in time t. 2. S equals to ut plus half at squared, meaning displacement equals to distance you've covered at old speed u plus extra due to speeding up. Then the third formula, v square equals to u square plus 2as, meaning link speed and distance without needing time. How to use the equations of motion? Yeah, write SUVAT and circle what you know, what you want. Then repeat the equation with those 4 letters. Let me give you an example. You drop a stone from a 45-meter cliff. Yeah, how long will it take to hit the ground? We know S is equals to 45, U is 0, A 9.8, T is not given. So you use S equals to UT plus half at squared. That will give you 45 equals to 0. My next point here will be forces cause motion. That will be brought to you under Newton's law. Basically, motion's description is kinematic. Newton's first law of motion, inertia, states that an object keeps doing what it's doing unless a net force acts upon it. Meaning, an object will remain at rest, or a body in motion will remain in motion at the same speed unless an outside force acts upon it. That's my basic understanding of it. The second law states that net force causes acceleration. So, meaning more force equals more acceleration, or more mass equals less acceleration. So this is why a truck needs bigger brakes than a bicycle. And the formula for that is F equals ma. Newton's third law of motion. Yeah, every action has an equal or opposite reaction, meaning you push on the ground, yeah, and the ground pushes you back to work. So let me give you another example. Rocket pushes gas down and gas pushes rockets up. My next point is special motion you need to know. Yeah, I'm giving you 2. That will be projectile motion and circular motion. So projectile motion basically means object launched. Yeah, only gravity acts after. So it will be broken down into 2, horizontal and vertical. Horizontal motion means no acceleration if we ignore a. That means it remains constant. Vertical means acceleration is not ignored. That means the trajectory is has a possibility to be affected. Next, circular motion. Circular motion means even at constant speed, direction changes, velocity changes, acceleration exists, which means it is a center-seeking acceleration. If you cut, let me give you an example now. If you cut the string of a spinning stone, it flies tangent, not outward, because no force holds it to the center anymore. My next point is momentum and energy in motion. Momentum, the formula for momentum is P equals to mv. It is a vector quantity. Newton actually wrote 2 laws as F equals to dp over dt. Conservation of momentum means if no external force, that means total momentum before equals total momentum after. That means it explains recoil and collisions. Momentum has to deal with work kinetic energy, potential energy, and work energy theorem. So, and let's not forget power. Common mistakes I make or see in when people talk about motion is if velocity is 0, acceleration must be 0. That's not true. If you throw a ball up now, the velocity is 0, but acceleration equals to minus 9.8 miles per second square. My next point is common mistakes people make or see. So, 1, if velocity is 0, acceleration must be 0. That's not true. If you throw a ball up now, when the ball is in the sky, the velocity is 0, but acceleration equals to minus 9.8 meter per second square. Yeah, that means it remains constant. So my second 2, motion needs a force. That's not true. Uniform motion needs 0 net force. Force is needed to change motion. My third point will be confusing the Earth's gravity with the universal gravity constant. There are different things. If you're gonna do mistake, so that means little g equals to 9.8 meters per second square. That's the Earth's gravity. And big G is universal constant. They are not the same, totally different. So a summary of my notes is motion equals to change of position. We describe it with displacement, velocity, acceleration, so on. If A is constant, use SUVAT. Forces cause acceleration via F equals to ma. Energy and momentum gives us other ways to solve problem using tracking force every second. So let me give you something to work on. So write this down. A car goes 60 kilometers per hour for 2 hours east, then 80 kilometers per hour for 1 hour east, for 1 hour west. Yeah, east west. So what's the total distance versus total displacement? Tell me, work it out and give me your answer. Thank you.